In this session, I am going to explain about the problems on transients. Problems on transients. So, the problems on transients. The examiner will ask the questions on these transients like there are two types of problems in these transients. One type is we need to find the values of I, di by dt and d square I by dt square at t is equal to 0 plus. This is one type of problem. We need to find these values, and another type of problem is we need to find I of t or v of t or IL of t, the current flowing through the inductor, or Vc of t. So like that the examiner may ask the questions on these two types of problems on these transients. In this session I will explain the problems on this type. Okay, so now you see one question on this. These are the questions. So in the given network, the switch is closed at t is equal to 0. So this is the network that he has given. The switch is closed at t is equal to 0 with 0 current in the inductor. That means initially there is no current flowing through the inductor. Find the values of I di by dt and d square I by dt square at t is equal to 0 plus. This is the question that I need to solve. So there is one type of procedure to solve this type of problems here. So what the procedure I will explain here. If we want to find this I or di by dt or d square I by dt square at t is equal to 0 plus, the procedure is, first thing we need to draw the circuit or the given circuit at t is equal to 0 minus. At t is equal to 0 minus. That means before switching action is done. We know that this is time axis. In this time axis it is 0, 0 minus, 0 plus, it is infinity, it is minus infinity. T is equal to 0 is the switching action. T is equal to 0 minus is the just before the switching action is done. T is equal to 0 plus is the instant just after the switching action is done. So here from minus infinity to 0 we need the circuit is under steady state condition, that we need to understand here, steady state condition. So while we are drawing the given circuit at t is equal to 0 minus, we need to assume that this is under steady state condition, so that if there is inductors, if there are inductors, then they have to be replaced. The inductors have to be replaced. Replaced with short circuit under steady state condition. Short circuit, and capacitors should be open circuit, because the circuit is under steady state condition. From minus infinity to 0 minus. Okay, so this is the first thing that we need to do. We need to draw the given circuit at t is equal to 0 minus by replacing the inductors with the short circuit and capacitors with the open circuit, because it is under steady state condition from minus infinity to 0 minus. Second thing here is we need to draw the given circuit at t is equal to 0 plus, at t is equal to 0 plus, and replace the inductors, or replace the inductors and capacitors with their equivalent circuits, I already explained these inductors and capacitors equivalent circuits at t is equal to 0 plus in the previous video. Next, write the integral differential equations. Integral differential equations. Then find the values of I, di by dt and d square I by dt square at t is equal to 0 plus. So this is the procedure that we need to follow. Okay, so this is the problem that I just explained. This problem here, this is a circuit. So in this circuit, the switch controls the electrical supply for this circuit, right? So at t is equal to 0, the switch is closed. That means that t is equal to 0 minus, the switch is in open position. What I need to find here is I di by dt and d square I by dt square at t is equal to 0 plus. That means just after the switching action is done, what are these values? So now you see, let me follow this procedure. And first I need to draw the given circuit at t is equal to 0 minus. So t is equal to 0 minus, first one. At t is equal to 0 minus, the circuit is, this is the circuit, the switch is open position at t is equal to 0 minus. So this is and since at t is equal to 0 minus, we are assuming that the circuit is under steady state condition, so that the inductors are replaced with short circuit and the switch is open position. Switch is open. Now what is the current that is flowing through this inductor? What I need here, I is, what is I mean is, I here is the current that is circulating here is I forgot to draw this loop here. This is I value. That means we need to find this I here. Here also the same thing, it is I of t. It is I of t. So this is I of t. So at t is equal to 0 plus, I need to find this I di by dt is d square I by dt square at t is equal to 0 plus. Okay. So this is 100 volts. It is 10 ohms. And at t is equal to 0 minus, since the switch is in open position, the value of the current that is flowing through this inductor is, that is this current. So that is IL of 0 minus is equal to 0, or I of 0 minus. If it is IL, this is, both are same here. It is I of 0 minus is equal to 0 amperes. Now this is the first step. Next step here is, I need to draw a t is equal to 0 plus. And I forgot to say here that t is equal to 0 minus. After drawing this circuit, we need to find the currents through the inductors t is equal to 0 minus. Or if there is a capacitor, the voltages across the capacitors, that is Vc of 0 minus. These things we need to calculate at t is equal to 0 minus. Purpose of drawing the circuit at t is equal to 0 minus is to find the current through the inductors. If there is a inductors, if there are capacitors, then we need to find the Vc of 0 minus. If both the inductors and capacitors are there, we have to find this currents through the inductors and voltages across the capacitors. Now at t is equal to 0 plus, drawing this circuit. The switch is closed now. Now if the switch is closed here, then the equivalent circuit of this inductor, the inductor is open circuited and there is the current source, it is the equivalent circuit of the inductor at t is equal to 0 plus. I explained this equivalent circuit of the inductors in the previous video, and it is I0, where I0 is the initial current. So this initial current is I0 is equal to, it is I of 0 minus, that is equal to this one, and it is I of 0 plus. So this current flowing through this is I of 0 plus, it is I of 0 minus. Now already this I0 we calculated, that is initial current, that is equal to 0 amperes. Now I of 0 plus, so I of 0 plus is nothing but I0. I of 0 plus is equal to I of 0 minus, because the inductor doesn't allow the sudden changes in current. From 0 minus to 0 plus, there will not be any changes in the currents. So I of 0 plus is equal to I of 0 minus is equal to whatever the current that is initially flowing, the same current will flow at 0 plus also, that is equal to I0, we calculated it as 0 amperes. So this. Now I of t at t is equal to 0 plus, we calculated, what is this? I of 0 plus, this I of 0 plus, that is equal to 0 amperes. So the first thing we calculated here. So here it is I value I calculated at t is equal to 0 plus. Next, di by dt, d square I by dt square, I need to calculate these two things here. So to find these two things, I need to draw the circuits for t greater than 0, for t greater than 0. To write the integral differential equations, I need to draw these circuits for t greater than 0. Next, write down here, draw this circuit here. So for t greater than 0 means the switching action is done after t is equal to 0. Here after t is equal to 0, the switch was closed here. Now replace this inductor with its equivalent circuit like this. For t greater than 0, this is the equivalent circuit of the inductor, and it is 10 ohms. Here also it is 10 ohms. It is 100 volts. It's 100 volts. Now this is the current I of t. This is the initial current I0. Already this initial current I0 we calculated as 0 amperes. Okay. Now to write the integral differential equations, use the KVL here. Using KVL, Kirchhoff voltage law, write down the equation for this. So it is 100, it is plus and minus, since the current is flowing in this direction, plus and minus. So here it is 100 minus 10 into I of t minus VL of t, the voltage across the inductor, VL of t is equal to 0. And we know that VL of t is nothing but L into di of t by dt. The value of L here is, forgot to write here, it is 1 Henry. The value of L here is 1 Henry. So it is 1 Henry. So now it is L means 1 into di of t by dt. The current flowing through the inductor is I of t, di of t by dt is equal to 0. Now I need to find the value of di by dt at t is equal to 0 plus. So write down this equation, rewrite this equation like this. di by dt is equal to 100 minus 10 into I of t. If I bring this term to the right side of this equation, we got this equation. Now di of t by dt at t is equal to 0 plus. So substitute t with 0 plus. 100 minus 10 into I of 0 plus. So 100 minus 10 into, already we calculated I of 0 plus is 0 here, so it is into 0. So 10 into 0 is 0, so it is 100. And the units for this is amperes per second, since it is di by dt. So di by dt at t is equal to 0 plus is 100 amperes per second. This is the second bit that we calculated like this. Next, to calculate the third bit, I am using the same equation here, that is 100 minus 10 into I of t minus di by dt is equal to 0, or this equation di by dt is equal to 100 minus 10 into I of t. I am writing the same equation here, di by dt, di of t by dt is equal to 100 minus 10 into I of t. What I have to find here, I need to find d square I by dt square. Again differentiate this equation with respect to time. Here is 100. If I differentiate with respect to time, it will become 0 because it is a constant, 10 into di of t by dt. We know that it is minus 10 into, just what I need to calculate, d square I by dt square at t is equal to 0 plus, I need to calculate it, and di of t by dt at t is equal to 0 plus. So minus 10 into di of t by dt. What is the value of di of t by dt? Just we calculated this, di of t by dt is equal to 100 ampere per second. So it is 100. So this will become minus 1000. Is minus 1000 amperes per second square. So this is the value of d square I by dt square at t is equal to 0 plus. So this is the procedure for solving this type of problems. So to find I di by dt, d square I by dt square at t is equal to 0 plus, we need to follow the procedure. That procedure is drawing the circuit at t is equal to 0 minus, and drawing the circuit at t is equal to 0 plus, and writing the integral differential equations by drawing the circuit for t greater than 0. After drawing all the circuits, we need to find the values of I di by dt, d square I by dt square. Just I explained like this. Next, so these are the answers. Next question here is, this is the question here. In the network shown in figure, the switch is closed at t is equal to 0. Same question, instead of inductor, here it is a capacitor, and this resistance value is changed from 10 ohms to 1000 ohms. With the capacitor uncharged, that means initially the charge in this capacitor is 0. That means the initial voltage is 0. That is V0 is 0 volts. We need to find the values of I di by dt and d square I by dt square at t is equal to 0 plus. So the same procedure I am going to follow here. So what that procedure here is, drawing the circuit at t is equal to 0 minus. For the circuit at t is equal to 0 minus, that means the switch is open position. So second question here. So at t is equal to 0 minus, this is the circuit. The capacitor will act as open circuit, we know that, under steady state condition, and the switch is open position. Now the voltage here is 100 volts, this is the 1000 ohms, and the capacitor value is 1 microfarad. I need not to write here because it is open circuited. And if there is a capacitor, what we have to find here, we need to find the voltage across the capacitor, that is Vc of 0 minus the voltage across the capacitor, that is Vc. So since it is at t is equal to 0 minus, it is Vc of 0 minus, that is equal to 0 volts, because no supply is connected to this capacitance, right? So Vc of 0 minus is 0 volts, and this is the current, this is I of t, and this current is I of 0 minus is equal to 0 amperes. Now I calculated these two things. Next I need to calculate at t is equal to 0 plus, I need to draw the same circuit. So this is at t is equal to 0 plus, after the switching action is done, just after the switching action is done. So the switch is closed here, it is 1000 ohms, and the equivalent circuit of this capacitor at t is equal to 0 plus, I can write like this, it is short circuited, and it is plus and minus, it is Vc of 0 minus, that is equal to 0 volts, that is V0, initial voltage is V0, that means initially it is uncharged, means V0 is 0 volts. So 100 volts it is and the current, that is I of 0 plus. Now there is a current flowing through this because it is closed here, and since the voltage across the voltage here is 0 volts, it will act as a short circuit. And if you want to find the current here, I of 0 plus is equal to 100 divided by 1000 ohms, that is 0.1 ampere. That means the capacitor can allow the sudden changes in the current, but it doesn't allow the sudden changes in the voltage. That means it is 0 minus 0 plus, it is infinity, it is minus infinity. At t is equal to 0, the switching action is done. So here the voltage across the capacitor, Vc of 0 plus is 0 volts here. Vc of 0 plus is 0 volts. That means whatever the voltage that is present at t is equal to 0 minus, the same voltage will be present at t is equal to 0 plus also. That means Vc of 0 plus is equal to Vc of 0 minus is equal to initial voltage, that is V0 is equal to 0 volts in this case. Okay, and now this is not my intention, here. My intention is to find the value of I of t at t is equal to 0 plus. I calculated it as 0.1 amperes. So I of t at t is equal to 0 plus is equal to I of 0 plus, that is equal to 0.1 amperes. So this is one thing I completed. Next thing, I need to find the values of di by dt, d square I by dt squares. So to find this di by dt, d square I by dt square, I need to draw the circuits for t greater than 0. For t greater than 0, that is to write the integral differential equations. The switch is closed. After t greater than 0, the switch is closed because the switching action is done at t is equal to 0. Now this circuit will be, for t greater than 0, I can write this circuit. This is the equivalent circuit. For t greater than 0. It is V0, that is equal to 0 volts, and this is a capacitance value, that is 1 microfarad. Capacitance value is 1 microfarad. Now this is 1000 ohms. Is 100 volts. This is I of t. Now write the KVL equation for this. It is plus and minus. This is 0 volts, means it will act as a short circuit. It is plus and minus. Now if I write this loop equation or KVL equation, 100 minus for the circuit, 100 minus 1000 into I of t, 100 minus 1000 into I of t, minus this voltage, the current flowing through the inductor, through the capacitor, we can calculate as IC of t is equal to C into dVc of t by dt. And if you want to find the voltage across the capacitor, Vc of t is equal to 1 by C into integral IC of t dt. Here IC of t, the current flowing through the capacitance is I of t. So the capacitance value is 1 microfarad. So the voltage across the capacitance here is 1 by C value is 10 power minus 6, 1 microfarad, 1 into 10 power minus 6, integral IC of t is I of t here, I of t dt, that is equal to, here it is dt, is equal to 0. Now let us substitute. What I have to find here is, I need to find the value of di by dt. If I differentiate this equation with respect to time, this value will be 0 minus 1000 into di of t by dt minus 10 power minus 6. If I bring to the numerator, it is 10 power 6. So this integration will become, there will not be an integration because of this differentiation, and integration will get cancels here. So 10 power 6 into I of t is equal to 0. Now bring this equation to this right side of this equation. 1000 into di of t by dt is equal to minus 10 power 6 into I of t. So it is 10 cube, it is 10 power, so this will become di of t by dt is equal to minus 10 power 3 into I of t. Now you see, what I need to find here is, I need to find di of t by dt at t is equal to 0 plus. So just you substitute here minus 10 cube into I of 0 plus. We calculated I of 0 plus as, for this it is 0.1 amperes, so it is 0.1. so if I calculate it, then di of t by dt, di of t by dt is equal to di of t by dt at t is equal to 0 plus is equal to minus 10 square or minus 100 ampere per second. So this is the di of t by dt for this type of for this problem, di of t by dt. Next I need to find d square I by dt square at t is equal to 0 plus. So I am using the same equation here, di by dt is equal to minus 10 cube into I of t di of t by dt is equal to minus 10 cube into I of t. This is the expression that I got here in this problem. Now I need to find d square I by dt square at t is equal to 0 plus. So I need to differentiate this above equation. So d square I by dt square is equal to minus 10 cube into di by dt at t is equal to 0 plus. I am calculating here at t is equal to 0 plus. So minus 10 cube into di by dt, just now I calculated this one as minus 100 amperes per second. So it is minus 10 cube into minus 10 square minus 10 power 5 ampere per second square. It is d square I by d square I of t by dt square at t is equal to 0 plus. So this is another problem. Right. I think it is minus into minus, sorry, it is di of t by minus into minus is plus here. So it is 10 power 5 ampere per second square. Next, third problem. So this is the third problem here. In the network shown in figure, the switch is closed, assuming all initial conditions as 0. Find I di by dt and d square I by dt square at t is equal to 0 plus. So this is the network. So the switch is closed. Actually the switch is closed at t is equal to 0. Here it is at t is equal to 0 should be there. So the switch is closed at t is equal to 0. T is equal to 0. Assuming all the initial conditions as 0. All the initial conditions means the initial current that is flowing through the inductor is 0. The initial voltage across the capacitor is equal to 0. So here we need to find the values of I di by dt, d square by dt square at t is equal to 0 plus. Okay. So the same procedure I am going to use here. So at t is equal to 0 minus, at t is equal to 0 minus, draw the circuit. This circuit is, the switch is under open position, so it is resistance. The inductance anyway it will act as a short circuit. The capacitor will act as open circuit under steady state condition, because at t is equal to 0 minus. It is 10 ohms. It is 10 volts, and the current that is flowing through this is I of 0 minus. Actually it is I of t, but at t is equal to 0 minus we drawn the circuit. It is I of 0 minus. Now this is capacitance and it is inductance, which was open circuited, it is short circuited. The current flowing through the inductor is initial current, that is I naught is equal to IL of 0 minus is equal to 0 amperes. Next, the voltage across the capacitance, initially it is not charged to any voltage and the switch is open position here, so Vc of 0 minus is equal to, it is this voltage is 0 volts only. Next, at t is equal to 0 plus, we need to draw the circuit, the same circuit by switching on the supply. Just after the switching action is done, it is 10 volts. It is, the switch is closed here. It is 10 volts, and this inductor will act as it has to be represented with this circuit, that is it is I naught, and it has to be represented with this capacitor will act as short circuited. So it is V naught, this value is V naught. So this is 0 volts, so it will act as short circuit. It is 0 amperes, so it will act as open circuit, and this current is I of 0 plus. So since it is open circuit, no current will flow through this. I of 0 plus is equal to I naught, or I of 0 plus is equal to I of 0 minus I of 0 plus, or I of 0 plus is equal to 0 amperes from this. IL of 0 plus is also I of 0 plus, that is equal to I naught, that is equal to I of 0 minus, that is equal to 0 amperes. So I calculated here I of t at t is equal to 0 plus is 0 amperes. So I calculated this I at t is equal to 0 plus. Now I need to find the values of di by dt, d square I by dt square. So for that I need to draw the circuit for t greater than 0. So here it is the circuit for t greater than 0. The switch was closed here. Now this is the resistance, and this has to be represented with its equivalent circuit, that is this one. It is I naught, this is I naught, the current source is I naught, and this value of the inductance here is, it is 1 Henry, and this is the voltage source, it is V naught, whose voltage is 0 volts, here it is 0 amperes, and this is capacitance I need to replace here. So this is the capacitance, whose value is 10 microfarad here. So it is 10 ohms, it is 10 volts, and this is the current I of t. Write down the KVL equation here. 10 minus 10 into I of t minus the voltage across this inductor is VL of t. It is plus and minus, it is plus and minus, it is plus and minus. Since it is 0 volts, and we need to consider this voltage here, minus it is the voltage across the capacitance is same thing, 1 by 10 into 1 by C into integral IC of t dt. So it is 1 by 10 into what is this 10 power minus 6, 1 by 10 into 10 power minus 6 integral, it is 0 to t, it is 0 to t I of t dt is equal to 0. Okay, and it is plus and minus, it is minus V naught. Write this minus V naught also, because in this case V naught is 0. Some cases are there in which the initial voltage also presents here, so I need to consider this V naught also. Okay, or otherwise the same expression can also be written like this: 10 minus 10 into I of t, same thing, minus VL of t minus the voltage across this capacitance is 1 by 10 into 10 power minus 6. Here I can write minus infinity to t here. So this is the initial voltage, this is the initial voltage, and now if I can write like this also, minus infinity to t I of t, the current flowing through this capacitance is I of t dt, that is equal to 0. The same I can write like this: 10 minus 10 into I of t minus VL of t minus 1 divided by 10 into 10 power minus 6. So this integration minus infinity to 0 I of t dt plus integral 0 to t I of t dt, and 10 minus 10 into I of t minus VL of t minus, it is 1 by 10 into 10 power minus 6 equal minus infinity to 0 I of t dt minus 1 by 10 into 10 power minus 6 integral 0 to t I of t dt, and this value is minus infinity to 0. So it is before the switching action is done, that means it is the initial voltage of the capacitor. So this initial voltage is minus V naught, and I write the same thing here, minus 10 into 10 power minus 6 integral 0 to t I of t dt. And this one also 10 minus 10 into I of t minus VL of t. The same thing I wrote here also. The same expression I wrote here in this expression. Okay, either I can write minus infinity to t. If I write minus infinity to t, you need not represent v0 here. If I write from 0 to t, it is minus v0, I need to represent here. Either ways I can write like this. Okay, so the same expression I'm going to rewrite here. 10 minus 10 into I of t minus VL of t minus 1 by 10 into 10 power minus 6 integral 0 to t I of t dt minus v0 is equal to 0. The same expression I wrote here. And VL of t is nothing but 10 minus 10 into I of t. VL of t is L into di by dt. What is the value of L here is 1 Henry. So 1 into di of t by dt minus 10 into 10 power minus 6, it is 10 power 5. If I bring to the numerator, it will become 0. So integral 0 to t I of t dt. Anyway, this v0 is 0. Now what I have to find here is di by dt at t is equal to 0 plus. So at t is equal to 0 plus, if I write this expression 10 minus 10 into I of t at t is equal to 0 plus minus di of t by dt at t is equal to 0 plus, it is minus 10 power 5. So t is equal to 0 plus means, so this dt value, dt is equal to difference between the time. So 0 to it is 0 to t. T value here is 0 plus. So 0 to 0 plus, that is it is 0, it is 0 minus, it is 0 plus. I am taking 0 to 0 plus. It is very small, that is it is approximately 0. So dt is 0 approximately. So this term is 0. 0 into something is 0. So the total integration will vanish here, that will become 0. 10 power 5 into 0, that is equal to 0 here. So now this will become di of t by dt at t is equal to 0 plus. It is equal to 10 into I of 0 plus. And 10 minus 10 into I of 0 plus, we calculated here. This value of I of 0 plus is, I of 0 plus here is 0 amperes, right? So it is 0 amperes. So it is 0. So this is equal to 10 amperes per second. Di of t by dt at t is equal to 0 plus. Next, use the same expression, this expression, to find the d square I by dt square. Differentiate this with respect to time. 0 minus 10 into ti of t by dt minus d square I of t by dt square minus 10 power 5 into differentiation integration will get cancelled, I of t is equal to 0. Now at t is equal to 0 plus, it is minus 10 into di of t by dt at t is equal to 0 plus is 10 minus d square I by dt square minus 10 power 5 into at t is equal to 0 plus I of 0 plus is, just we calculated, that is we substitute here, that is 0. So 0 is equal to 0. So d square I by dt square, this at t is equal to 0 plus, at t is equal to 0 plus is equal to minus 100 ampere per second square. So this is how we need to solve this question. So the answers are t is equal to I at t is equal to 0 plus is 0 amperes, di by dt at t is equal to 0 plus is 10 amperes per second minus 100 amperes per second square. Next, fourth question. In the network shown in figure, the switch is changed from position 1 to position 2 at t is equal to 0. Steady condition reached before switching action. Find the values of I dI by dt and d square I by dt square t is equal to 0 plus. This is the circuit. In this circuit, the switch is changed from position 1 to position 2. That means initially this switch is at position 1. Now at t is equal to 0, the switch is shifted or moved from position 1 to position 2. Steady condition reached before switching action is done. That means at t is equal to 0 minus, that is just before the switching action, the switch is at position 1. Whenever the switch is at position 1, the steady conditions are reached. That means whenever the switch is at the position 1, the circuit is under steady state. We need to find the values of I dI by dt, d square I by dt square at t is equal to 0 plus. So as it is, the procedure is same. What the procedure here is, at t is equal to 0 minus, t is equal to 0 minus, draw the circuit. This circuit is just before the switching action. That means the switch is at position 1. This position 1, and this is 10 ohms. This is the fourth question. And under steady state condition, this inductor will act as short circuit, and it is position 2. This is no way connected to this circuit. It is 20 volts. Okay. Now this current, what is this current is I of 0 minus or IL of 0 minus. The current flowing through the inductor, IL of 0 minus, it is 1 Henry. So now I of 0 minus is equal to, I need to find what is this current, 20 volts. This current will circulate like this. This current will circulate like this. So I of 0 minus is equal to 20 divided by 10. That is equal to 2 amperes. Okay. So the current that is flowing through the inductor initial current is I0 is equal to 2 amperes. At t is equal to 0 plus also, the same current will flow through the inductor because the inductor doesn't allow the sudden changes in current. So at t is equal to 0 plus, draw the circuit. It is 20 volts. This is position 1. Now the switch is closed. It is 0, 0 minus, 0 plus. It is infinity. It is minus infinity. The switching action is done at t is equal to 0. T is equal to 0 minus, the switch is at position 1. At t is equal to 0, the switch is moved from position 1 to position 2. And now at t is equal to 0 plus, the switch is at position 2. Now the switch is at position 2. So this is the resistance. This value is 20 ohms. This is 20 ohms. Okay. And now it is 10 ohms. And replace this inductor with its equivalent circuit, that is this one. This is the equivalent circuit of the inductance, that is I0 is equal to, now it is 2 amperes. Now this one, this is, now it is I of 0 plus. Now I of 0 plus from this circuit, I of 0 plus is equal to, so this current flowing through this current will flow like this. So I of 0 plus is equal to I0, that is equal to I of 0 minus, that is equal to 2 amperes. So I calculate the value of I of t at t is equal to 0 plus is equal to 2 amperes. Okay. Next, I need to find the di by dt and d square I by dt square for the circuit. So to find this di by dt, I have to draw the circuit for t greater than 0 and write the integral differential equation. So for t greater than 0, this circuit, this is the circuit. So after t greater than 0, the switch is at position 2 only. It is position 2, it is position 1, it is position 2. The switch is at position 2, and this is like this. The inductor, replace the circuit like this. I0 is equal to 2 amperes, and the inductance value is 1 Henry. This value is 10 ohms. It is 20 ohms. It is 20 volts. The current is I of t. Now this is plus and it is minus. It is plus and minus. It's plus and minus. Write down the KVL equation so that we can get the integral differential equation. So now it is minus 20 into I of t. It's minus current limit 10 into I of t, minus current limit L into L is 1 here, di of t by dt is equal to 0. Now this is di of t by dt is equal to 30 minus 30 into I of t. 20 plus 10 is equal to minus 30. Now di of t by dt at t is equal to 0 plus is equal to minus 30 into I of 0 plus. So the value of I of 0 plus we calculated here as I of t at t is equal to 0 plus, that is equal to 2 amperes here. That is into 2. So it is minus 60 amperes per second. So this is di of t by dt at t is equal to 0 plus. This is the value. And if you want to calculate a d square I of t by dt square, you differentiate this equation, d square I of t by dt square, that is equals to minus 30 into di of t by dt, and it is minus 30 into di of t, d square I of t by dt square at t is equal to 0 plus if you want to calculate it. So di of t by dt at t is equal to 0 plus, that is minus 60. So 361,800, minus into minus plus, so it is ampere per second square. So this is the value of this d square I of t by dt square. So these are the answers that we got: minus 60, 1800 amperes per second square. I have 0 plus is 2 amperes. Okay. Next, the fifth question. This is the fifth question. The same question, instead of inductor it is capacitor, and the values of the resistance and voltages are changed here. So in the network shown in figure, the switch is changed from position 1 to position 2 at t is equal to 0. Steady conditions are reached before switching action is done. Find the values of I di by dt and d square by dt square at t is equal to 0 plus. So this is the circuit. Initially the switch is at position 1, and now at t is equal to 0, the switch was closed from position 1 to position 2. The switch is moved from position 1 to position 2 at t is equal to 0. Steady conditions are reached before switching action. That means if the switch is at position 1, the steady conditions are reached. Okay, so these are the things that we need to calculate. The same question. So let me proceed with the same. What is it? At t is equal to 0 minus. It is fifth question. At t is equal to 0 minus. This is 30 volts, and this is position 1, it is position 2, and this is the resistance is 10 ohms, and at t is equal to 0 minus, the switch is at position 1, and also it reaches to steady state condition. It is 20 ohms, and here it is this capacitance will act as open circuit here under steady state condition. This capacitor will act as open circuit under steady state condition. So now it is 1 microfarad actually, and it is 20 ohms. Now it is plus and minus. So initially it is charged to Vc of 0 minus. So what is the voltage across this capacitance? Whatever the voltage that is present here, the same voltage will be present here, because the current, there is no current flowing through this. So if you have any doubts, you can also apply the KVL for this loop. It is 30 volts plus and minus. No current is flowing through this. So 30 minus 20 into I of here it is what is this current? I of 0 minus. So I of 0 minus is 0 amperes because it is open circuited, minus Vc of 0 minus is equal to 0. It is KVL equation for this. So I have 0 minus is 0, this value is 0. So Vc of 0 minus, if I bring this to right side of this equation, it will become 30 volts. So this is the initial voltage. So Vc of 0 minus is equal to 30 volts, that is equal to V0. And the current, initial current is I of 0 minus is equal to 0 amperes since it is open circuited. Now at t is equal to 0 plus, at t is equal to 0 plus, t is equal to 0 plus, draw the circuit. The switch is moved from position 1 to position 2, and now the switch is at position 2 at t is equal to 0 plus. And replace this capacitor with this equivalent circuits. So this capacitor equivalent circuit is this V0, that is Vc of 0 plus or Vc of 0 minus V0, and this is open circuit, short circuited. This will act as short circuited at t is equal to 0 plus. It is 30 volts, it is 10 ohms, it is 20 ohms. V0 is 30 volts, and it is Vc of 0 plus, that is equal to 30 volts only. So that is equal to Vc of 0 minus, that is equal to V0. This is inductor capacitor doesn't allow the sudden changes in voltages, so that whatever the voltage at t is equal to 0 minus, same voltage will be present at t is equal to 0 plus also. Now what I need to find, this is the current I of 0 plus. I need to find this I of 0 plus. Here, since actually this is plus and it is minus, actually the current, it will circulate the current in this direction, but I am assuming, but we are assuming that the current is in this direction. It is plus and minus, it is plus and minus. Okay, now apply the KVL equation here. It is minus 10 into I of 0 plus, minus 20 into I of 0 plus, it is minus V0, that is equal to 30, is equal to 0. So here it is 30 I of 0 plus is equal to minus 30. So I of 0 plus is equal to minus 1 ampere. So this is the current initially, flowing through that, that is minus 1 ampere. I of 0 plus is equal to minus 1 ampere. Next, to find di of t by dt, d square I of t by dt square, I need to draw this circuit for t greater than 0. So for this problem, I need to draw the circuit for t greater than 0. For t greater than 0, the circuit, I can replace, I can draw the circuit like this. It is 10 ohms, position 2, position 1. The switch is at position 2 now, because for t greater than 0 it is 30 volts, and this is the initial voltage here is V0, that is equal to 30 volts, and this one will act as a capacitance, so whose value is 1 microfarad, and it is plus and minus 20 ohms because the current is flowing like this I of t. It is plus and minus, so it is plus and minus, it is plus and minus. I write the KVL equation for this. It is minus 10 into I of t, minus 20 into I of t, minus 30. So it is minus, I already explained this, 1 by c 10 power minus 6 into integral. It should be 0 to t only, but not from minus infinity to t. It is from 0 to t, I of t dt, that is equal to 0. Why it is from 0 to t, I already explained in this video itself. Okay, it is minus 30 into I of t minus 10 power 6 into integral 0 to t I of t dt, that is equal to 30. So I have to find the di by dt here. So differentiate this equation. Minus 30 into di of t by dt minus 10 power 6 into I of t, that is equal to 0. So di of t by dt is equal to minus 30 into this 10 power 6 into I of t. So di of t by dt is equal to minus 10 power 6 divided by 30 into I of t. So di of t by dt, di of t by dt at t is equal to 0 plus is equal to minus 10 power 6 by 30 minus 10 power 6 divided by 30 into I of 0 plus. I of 0 plus, we already calculated the value of I of 0 plus. Here it is, I of 0 plus is minus 1 ampere. So it is minus 1 ampere. So if I find this, value of this I of 0 plus, if you find this di of t by dt at t is equal to 0 plus is it is minus into minus plus it is, so 0.33 into 10 power 5 ampere per second. So di of t by dt at t is equal to 0 plus. Okay, right. If I want to find the d square I by dt square, then I need to use this equation or this equation. I can use this equation. D square I by dt square is equal to minus, it is 0.33, it's minus 0.33 into 10 power 5 into di by dt. So at t is equal to 0 plus, if you want to calculate at t is equal to 0 plus, that is equal to minus 0.33 into 10 power 5 into di by dt at the point is 0.33 into 10 power 5, that is equal to, it is minus 1.1 into 10 power 9 ampere per second square. So this is the answer, d square I by dt square at t is equal to 0 plus. Next, let me solve these two problems also, so that I can stop this class. Okay, in the network shown below, the switch is changed from position 1 to position 2. Same question, but instead of resistance, it is inductance now. This value of the inductance, just the value of the inductance here is 1 Henry. So it is 40 volts, it is 20 volts, 1 Henry, 1 microfarad. Same question, the switch is initially at position 1, at t is equal to 0, it is shifted from position 1 to position 2. So what are the values of I, di by dt, d square I by dt square, just after the switching action is done? It is the question. So at t is equal to 0 minus, same thing, at t is equal to 0 minus, draw the circuit. The switch is at position 1, resistance, it is under steady state condition, because from minus infinity to 0 minus or 0, the switch is at position 1, and whenever the switch is at position 1, it is under steady state condition. Under steady state condition, the capacitor will act as open circuit, and this inductor will act as short circuit. Actually, no current is flowing to this, I need not to consider this. Okay, anyway it will act as short circuit. So it is 40 volts, 20 volts, it is 1 microfarad, and the voltage across this one is Vc of 0 minus, that is equal to this voltage only. I already explained this type of problems in the previous case, that is 40 volts only. and the current that is circulating through this is I of 0 minus. So this current will flow like this, I of 0 minus. So I of 0 minus is equal to I of 0 minus is equal to 40 divided by, sorry, since it is closed open circuit here, so it is no current is flowing through this, so I of 0 minus is equal to, it is 0 amperes. Now at t is equal to 0 plus, just the switch is moved from position 1 to position 2. Now draw the circuit here. This is an inductance. This inductor will act as open circuit, and previously the current flowing through this inductor is 0. So this current flowing through the inductance is 0 in any direction. I0 is equal to 0 amperes. Current is 0 amperes. Now this is at position 2, is 20 ohms, and this one will act as 40 volts. This one will act as short circuit like this. So this current I0 is 0. This current is also I of 0 plus is also 0 amperes. So this is 0 amperes only. Next, for t greater than 0. Draw the circuit. It is 40 volts. So it is 40 volts. It is at position 1, it is position 2 and position 1. So it is position 2. Initial current is 0 amperes. It is I0 0, and this is inductance is like this. Inductance has to be connected like this, and it is position 2, 20 ohms, and this is 40 volts. This is the capacitance. The value of the capacitance is 1 microfarad. It is 1 Henry, 1 microfarad. This current direction is like this. So it is plus and minus, plus and minus, plus and minus, plus and minus. So we use this KVL equation. So it is minus VL of t, the voltage across inductance, minus 20 into, it is I of t, minus 20 into I of t, minus 40 minus VC of t is equal to 0. So the voltage across the inductor is minus L into di by dt. L value is 1 into di by dt, minus 20 into I of t, minus 40. This value of the capacitance is 1 by C into integral IC of t dt. So 1 by C value is 10 power minus 6. 1 microfarad is 1 into 10 power minus 6, integral 0 to t I of t dt is equal to 0. Now di of t by dt is equal to, if I bring this term to the right side of this equation, minus 20 into I of t, minus 40 minus 10 power 5 into integral 0 to t I of t dt. So di of t by dt at t is equal to 0 plus is equal to minus 20 into I of 0 plus minus 40 minus 10 power 5 into, so this dt value is 0, because from 0 to 0 plus the time is very less, that is dt is 0, dt is 0 plus minus 0. This is the value of dt. So it is approximately 0 only. Dt value is 0 only. So 0 into something is 0. So this total term will become 0. So this is 0. So minus 20 into I of 0 plus. We calculated this I of 0 plus as 0 amperes here. So it is 0 minus 40. So di of t by dt at t is equal to 0 plus is equal to minus 40 ampere per second. And if you want to calculate d square I of t by dt square, let us use this expression here and differentiate once again this expression d square I by dt square is equal to minus 20 into di of t by dt minus 40 is 0. 40, if I differentiate this one, it will become 0. Minus 10 power 5 into it is I of t. So d square I by dt square t is equal to 0 plus, t is equal to 0 plus, t is equal to 0 plus, that is equal to minus 20 into di by dt at t is equal to 0 plus is minus 40, minus 10 power 5 into t is equal to 0 plus, I of 0 plus is 0, so it is 0, so it is 800 ampere per second square. So this is d square I of t by dt square is 800 ampere per second square. So these are the answers. 800 ampere per second square minus 40 amperes per second, minus 40 ampere per second, 800 amperes per second square. I have 0 plus is 0 amperes. Next, last question, 7th question. In this network, the switch is changed from position A to position B. Same thing, instead of 1 and 2, we change it from position 1 to position A and position B. Instead of 1 and 2, A and B are replaced here. And previously it is capacitance, it is inductance. Now it is inductance and capacitance. That is only the change. Now let me draw at t is equal to 0 minus. At t is equal to 0 minus, the circuit will be, this is A position and the switch is at position A only. So this is when under steady state condition, this inductor will act as short circuit, and if there is a capacitance, it will act as open circuit. It is position B, it is 100 volts, it is 1 kilo ohm, it is 1 Henry actually, it is short circuited. Now this current, I think it is the current I of t. So this current is I of 0 minus. I of 0 minus is equal to, it is 10 divided by 1 kilo ohm, sorry 100 divided by 1000. How much it is? 10, 100 divided by 1000. 1 kilo ohm is 1000. It is 0.1 ampere. Now at t is equal to 0 plus. And what is the voltage across this one? Vc of 0 minus. The voltage across the capacitance is 0 volts. No supply is applied for this capacitance here, so 0 volts only. Now t is equal to 0 plus, this is 100 volts, and now the switch is at position B. It is position B and it is position A, and it is 1 kilo ohm. Now this inductance, I can replace this inductance as its equivalent circuit at t is equal to 0 plus. So this is I naught, this value is I naught, is this is the value of I naught. So this is I naught is equal to 0.1 ampere, and the capacitance, so this capacitance will act as it is a voltage, and this is will act as a short circuit. So voltage value is V0, this is V0, that is equal to 0 volts only. That means it will act as a short circuit, and the current will flow like this. So it is I of 0 plus. So I of 0 plus is equal to, this current will flow like this. So I of 0 plus is equal to I naught is equal to 0.1 ampere. So we calculate this I of 0 plus. Next, for t greater than 0, for t greater than 0, the same circuit, draw the circuit, and the switch is at position B, it is A, and position B it is 100 volts, and it is replaced with the capacitance, and V0 value is 0 volts, and this capacitance value is 0.1 microfarad. It is 0.1 microfarad, and this switch is at position B, it is 1 kilo ohm, and this is replaced, this inductance is replaced with its equivalent circuit, that is like this. Psi naught is equal to 0.1 ampere, and it is the value of L here is 1 Henry, like this, and this is I of t. Now this value of this plus and minus, it is plus and minus. I need to find this I of t. So it is now plus and minus. Okay. If I apply the KVL, minus Vc of t, the voltage across the capacitance, it is plus and minus, it is plus V naught minus 10 power 3 into I of t. 10 power 3 is 1 kilo ohm, minus VL of t is equal to 0. Vc of t is 1 by C into this C value is 0.1 microfarad, integral I of t dt. V naught value is 0 volts anyway, minus 10 power 3 into I of t. VL of t is L into di of t by dt. So L is 1 into di of t by dt is equal to 0. Now di of t by, so it is from 0 to t, 0 to t only. So within this okay, what I need to find here, di by dt. So di of t by dt is equal to minus 10 cube into I of t, minus 0.1 is 10 power minus 1, 10 power minus 6. So it is 10 power 7 into integral 0 to t I of t dt. So di of t by dt at t is equal to 0 plus, it is equal to minus 10 power 3 into t is equal to 0 plus, it is di of 0 plus, minus 10 power 7 into, so dt value is 0, because from 0 to 0 plus it is 0, dt is very less, dt is equal to 0 plus minus 0, that is it is 0 only. So 0 into something is 0, so this total term will become 0, so it is 0. So it is minus 10 power 3 into I of 0 plus, I of 0 plus is 0.1 ampere, so it is 0.1, so it is minus 100 ampere per second. It is di of t by dt at t is equal to 0 plus, so it is minus 100 ampere per second. 0.1 ampere is also. Next, d square I of t by dt square. To find this d square I of t by dt square, just to differentiate this equation once again with respect to I, d square I by dt square of t by dt square is equal to minus 10 power 3 into di of t by dt minus 10 power 7 into I of t. So if I differentiate this equation, integration differentiation will get cancelled here. So d square I of t by dt square at t is equal to 0 plus is equal to minus 10 power 3 into di of t by dt at t is equal to 0 plus. What is the value? It is minus 100, minus 10 power 7 into I of 0 plus. So I of 0 plus value is 0.1, so it is 0.1. So if I calculate this one, then I will get the value of, I will get this value. Otherwise you try to calculate this minus into minus, it is 10 power 5, it is minus 10 power 6, 10 power 6. So it is if I take 10 power 5 as a common here, 1 minus 10, that is equal to minus 9 into 10 power 5 ampere per second square. This is the value of d square I of t by dt square at t is equal to 0 plus. So this is how we need to solve the problems. So the procedure is same. At t is equal to 0 minus, draw the circuit and assume that this circuit is under steady state condition from minus infinity to 0 minus. Under steady state condition, the inductor will act as a short circuit and capacitor will act as a open circuit, and draw the circuit. Second step is draw the circuit at t is equal to 0 plus. So replace the inductors and capacitors with its equivalent circuits at t is equal to 0 plus, and find the values of the currents flowing through the inductors and the voltages across the capacitors. Next, third step is To find the di of t by dt and d square of t by dt square, we need to write the integral differential equations. To write the integral differential equations, we need to draw the circuits for t greater than 0. For t greater than 0, the inductors and capacitors are replaced with its equivalent circuits. So this is the procedure. Okay, with this session I will stop here. Next class I will explain the problems, how to solve the problems in RL circuits, and that is to find the I of t and V of t, Vc of t, IL of t, and the derivation of IL of t, Vc of t, time constants. All these things I will explain in next class. Okay.